Okay, so we've done a few problems with u substitution, and it seems like u substitution is this golden bullet that can solve all of our problems. But unfortunately, that's not the case. Here, I want to look at an example where u substitution simply does not work. So let's say we want to find the integral of minus 8 times 3 minus 4x squared, quantity squared. We might be tempted to say, oh, look, I can just let that be our u, and then du is just minus 8x dx, and then we just multiply by 1 in a really clever way. So we have the integral of u squared times 1 over x times minus 8x dx, and boom, we're good to go. And so that becomes the integral of u squared times 1 over x times du. But now we have two variables floating around. We have x's and u's, and we have this guy here, so it tells us to take the integral with respect to u, but what do we do with this extra variable? We can't just pull a variable out of the integral. It looks like u substitution doesn't work. And in this case, it turns out not to work. If we want to solve this integral, the easiest thing to do is just to multiply everything out. So this integral becomes the integral of minus 72 plus 192 x squared minus 128 x to the fourth dx. Now that's obviously going to take some work to figure out. I just saved you all some steps. But from here we can just apply our standard integration rules, and we see that this is going to become minus 72x plus 192 over 3x cubed plus 128 over 5x to the fifth plus some constant c. Now, in general, multiplying out like this will always work. It's just sometimes it's a lot harder than just doing a simple u substitution. All right, let's take a look at one more example. We want to find the integral of 7x squared times the square root of x cubed plus 1. So we begin, as always, by writing everything in exponential notation. So this becomes 7x squared times x cubed plus 1 to the 1/2 power dx. And now, the good news is we can let this be our u, and so then we have du equals 3x squared dx. And so this whole integral becomes the integral of u to the 1/2 times 7x squared dx. All we need to do is multiply by 1 in a clever way. In order to make 7x squared dx look like 3x squared dx that we need in order to do the u substitution, we just multiply as follows. We get the integral of u to the 1/2 times 7/3 times 3/7 times 7x squared dx. And so now 3/7 times 7x squared dx, that's going to simplify to become, let's rewrite everything we have, the integral of u to the 1/2 times 7/3 times, now 3/7 times 7 is just 3, x squared dx. And look at that, now we can do the substitution that we need. So bringing the constant in front to make everything easy, we have the integral of 7/3 u to the 1/2 du. And now we just add 1 to the exponent, so we get u to the 3/2. And we multiply by the reciprocal, so we have 2/3 times 7/3 times u to the 3/2 plus c. This becomes 14 over 9 times u to the 3/2 plus c. And remember, u was x cubed plus 1, so we get 14 over 9 times x cubed plus 1 to the 3/2 plus c.